Okay, so gentlemen, we will study now Pythagoras theorem, a very important property in a triangle. Already we discussed many of the properties in a triangle. Okay, and also we discussed about different types of triangles. We discussed about equilateral triangle, isosceles triangle, then scalene triangle, and then on the basis of angle, the classification of triangle already we discussed, that is acute angled triangle and obtuse angled triangle. Okay, so many of the properties we discussed, and here today we are going to discuss about Pythagoras theorem, which is a very important derivation, and also its applications are much more, you can say many more applications are there in our practical day-to-day life. So in that case, this particular theorem becomes very important for our students. Okay, it is applied at many places. You would have seen that in your geometry box. Okay, you are having set squares. Okay, so set square is also, you can say, one of the example where you can see the shape right angle triangle, right? So Pythagoras theorem is applicable only for a right angle triangle. That part you please note it. Okay, note it that this theorem will be applicable only in a right angled triangle. Okay, so in a right angle triangle, three things are there. Three sides in a triangle, already three sides will be there, but here one angle will be 90 degree. Okay, so it is a right angle triangle. Now in this right angle triangle, one side will be perpendicular to another side. So suppose the figure what I have shown to you, if we are taking it, then AB suppose we are considering as perpendicular, and BC then it will become base. Okay, so if one side you are taking as perpendicular, perpendicular means what? Which is making 90 degree with another side. So the line segment which makes 90 degree with the another line segment, so that will be called as perpendicular. Okay, so each one can be perpendicular to each other. Two sides can be perpendicular to each other. Okay, not can be are. Two sides always they are perpendicular to each other if the angle between them is 90 degree. Right. So what it is there, if one we are considering it as perpendicular, another one will become base. Right. So in the figure what I have shown to you, in that figure it is already there that ABC is a triangle in which AB I am taking it as perpendicular and BC I am taking it as base. So AC will automatically will become hypotenuse. Okay, AC will be becoming hypotenuse, right? So by taking this perpendicular and base and hypotenuse, we will be deriving Pythagoras theorem. So the theorem states that in the right angle triangle ABC, as it is shown in figure, perpendicular square of the two sides, sum of the squares of the two sides will be equal to the square of the third side. Okay, when the angle is a right angled triangle. Right, when the angle is a right angle triangle, sum of the squares of its two sides will be equal to the square of the third side. Okay, so this is called Pythagoras theorem. Now based on that Pythagoras theorem, we can find out Pythagorean triplet. So what is that Pythagorean triplet? With any number, any integer, you will be able to find out that which three number will be forming. You can say solving means which three number will be satisfying the criteria of Pythagoras theorem. Right, Pythagoras theorem. So what it is? Suppose you take that one side is a square, perpendicular you take as a square, and base you take it as b square. Okay, means b. Its length is b, and its perpendicular, its length is a. Then a square plus b square is equal to c square, where a, b, c are the natural numbers. Okay, a, b, c belongs to natural number, right? Because it is showing that length of the side, so length of the side we cannot write it as negative. Okay, so then a, b, c are called Pythagorean triplet. So in which case how that a and b and c will be called as Pythagorean triplet? When A will be equal to m square plus m square minus n square. Okay, we'll tell, and m and n also natural numbers are there. So when A is equal to m square minus n square, and B is equal to 2mn, and C is equal to m square plus n square. C is equal to m square plus n square. Right? Okay. So now when we are going for, suppose we want to find out, and I have taken an example that m is equal to 5 and n is equal to 4. See, m square minus n square should be greater than 1. Okay, it should not be less than 1. So it should not be negative. That's why I have written m is greater and n is smaller. So always we should take that type of number where we are getting positive. So after subtraction we will get positive number. Okay. So A, as it is, we have discussed here. So it is m square minus n square. So we went for 25 minus 16 and that we got 9. Right. Similarly, B is what? 2mn. 2mn. Right. So this 2mn, 2 into 5 into 4, and we have got 40. 40. Similarly, we went for finding out C, that is m square plus n square, that is 25 plus 6, 41. Okay, 25 plus 16, 41. And then when we checked it, that A square, B square and C square we found out separately. And then we have written as A square plus B square is equal to C square. So we went for putting the values in the, you can say, formula given by Pythagoras theorem, and we found that it is satisfying. A square plus B square is equal to C square. It's satisfying the Pythagorean theorem. So that's why any number, okay, if we are taking, then it will become Pythagorean triplet when we are following like A is equal to m square minus n square, B is equal to 2mn, and C is equal to m square plus n square, then it will form Pythagorean triplet. Okay, so it is a very important property, gentlemen, you need to remember. Okay, thank you. So bye. Please like it and share.